My name is Kelly here with Esri, and I'd like to welcome and thank you for joining us today. And before we officially start this webinar with the presentations, I just want to go over a few items with you all. This webinar is being recorded, and you will receive a follow-up email with a link to the recording location and any additional resources once those are made available. You are encouraged to post your questions during the presentation and demos. You can type them in at any time into the questions chat box in your GoToWebinar control panel, and we will be collecting these and addressing them in a Q&A session at the end of the presentation. So today we're going to be discussing unlocking your data's potential with spatial analysis and data science in ArcGIS. And with that, I'll go ahead and turn it over to our presenters today to introduce themselves, starting with Hannah Shumway.
Hi everyone, my name is Hannah. I'm a solution engineer on our Intel team. I work out of our DC office here at Esri, and I'm really excited to dive into data science and spatial analysis with you today. So I'll pass it over to Parker.
Hey everyone, my name is Parker Warnstein. I'm a senior solution engineer on Esri's defense team. I do a lot of work with Python. I have background in computer science, so I'm excited to share with you guys today a few helpful tips and tricks on how you can use some of the built-in ArcGIS functionalities to access your data using Python. And I'll present it to, or pass over to Linda.
Yeah, great. Thanks, Parker. Hey, everyone. Linda Peters here. I'm really pleased to be with you here today. I've been in the GIS community for more than 25 years. I focus here at Esri on helping national government organizations understand how to apply our technology, specifically in area of statistics and mapping. And we're really excited. We've got a great agenda for you here today. For bandwidth considerations, we're all going to turn off our videos here, but we'll all be here with you during the time. But unless we're presenting, we're going to have videos off. So I'm going to move us forward now and take a look at the agenda quickly for today, because we've got a lot of good content to cover. So again, glad you're all here with us. We're going to explore today how you can discover patterns and trends in your data with capabilities across the ArcGIS suite. So we'll take a look at some things in Pro and Insights as well as notebook servers here this morning. But I wanted to start with a little context on data science and GIS, and then following that, we'll invite Hannah and Parker to show you some examples. So, of course, we're going to talk about data science, but it all starts with the ArcGIS platform. And many of you know already that ArcGIS is a comprehensive geospatial platform. It's open, it's services-based, it's distributed, and, of course, extendable. And it provides us now smarter ways to perform analysis and data science. And while GIS itself is advancing, in spatial modeling and analysis, it's advancing so rapidly. It's creating whole new insights. For example, in big data in real time, looking at multidimensional data with voxels, looking at object detection using AI and machine learning, remotely sensed data coming from so many different sources. These are integrating and assisting people by leveraging the latest technology and being open to the whole world of open data science and all the new tools that are emerging across that community. And of course, ArcGIS itself continues to evolve, integrating so many new innovations in data measurement and compute and in science. Again, looking at new tools for computing, faster machines are helping us, of course, AI, machine learning, supporting cloud native environments, now Kubernetes. There's just so much happening in the technology space. Being able to divide up our software into microservices as an example and distribute that and bring it together dynamically. And so in the science area, we're also integrating spatial temporal algorithms we've created, as well as open science tools that can enrich and make the platform better and stronger. So we're going to start out today talking a little bit about the building blocks of spatial data science. Now, some of you may be familiar with this, but it all begins with data engineering. From there, we'll move on to look a little bit at visualization and exploration, conducting spatial analysis, perhaps using models and scripts, and then finally sharing our results and collaborating. Now, data engineering is perhaps not the most exciting task, but it is most important. It's all about cleaning your data and getting it ready to put into a tool or model. And this is where most analysts in data science spend most of their time. Now, many of us may also be familiar with data visualization, whether that's maps or charts. We want to look at data in a variety of ways. And the example here may be one that you've seen before. We have to be able to effectively communicate the underlying data. Using appropriate methods can help. As you see here, we've got two different methods, both natural breaks and quantiles. But it's even better if we can minimize the subjectivity in the map and turn the map into information. And that's part of where data science and spatial analytics can also help us, helping us to understand where things have changed and perhaps even where to direct resources. Now, as we move into spatial statistics, we're talking about a set of exploratory techniques for describing and modeling spatial distributions, patterns, processes, and relationships. And this is what Hannah's going to focus on. We also look at AI and ML. Sometimes you may hear us call it GeoAI. We see many innovations here. The tools are becoming easier to use and are making GIS really smarter, allowing us to integrate with many of the familiar open source tools that you may be using today, whether that's R or Pandas, TensorFlow. There's so many others. In modeling and scripting, equally important, helping us save a lot of time on repetitive tasks and also to minimize errors. And again, finally, in sharing our work, analysis is really driving action through storytelling. Now, ArcGIS Notebooks really sits at the intersection of ArcGIS and open data science. Again, I've talked about some of the open source tools that we are using and we see many of you using. But with that, what I'd like to do is turn it over to my colleague Hannah to present to us and show us some of this, starting with Pro. So Hannah, I'm going to, excuse me, share over to you.
Great. Thanks so much. Let me show my screen. Great. Are y'all seeing ArcGIS Pro right now, Linda?
Yes. Excellent.
Awesome. So today we're going to start out in ArcGIS Pro talking about some spatial statistics, space-time pattern mining, and deep learning work that we can do in Pro. And the first thing I want to do is introduce to you the data set that we're going to be working with today. So this is the Armed Conflict Location and Event Data Project, or ACLED. And ACLED collects real-time or near real-time data on the locations, dates, actors, fatalities, and types of all reported political violence and protests in many areas around the world. And today we're going to be focusing in on South Sudan. As we zoom in to South Sudan here, there's been a civil war in South Sudan since about 2011, and this has ostensibly ended and started back up a couple of times, but there still is ongoing conflict. And so we brought in some of this armed conflict location and event data. And if we open up our attribute table, we can already see that the data includes information not just about that location, but also all of these other variables, including event type, date, actors, etc. And I've already gone ahead and visualized the data based on this event type. And you can see that based on the different colors of the dots. And here within ArcGIS Pro, we can even just with a click figure out how many dots make up battles, violence against civilians, strategic developments, different sorts of types of events. And it's very quickly clear that battles and violence against civilians have been the two most common types of conflict events in South Sudan since 2011. And so now that we have this sort of top level situational awareness of what has been going on in South Sudan, we can start to dig deeper with the spatial stats tools in ArcGIS Pro. So the first one I'm going to talk about today is neighborhood summary statistics. And neighborhood summary statistics is a tool that's actually new to ArcGIS Pro 2.7, and it has a simple idea, which is that you can define your own neighborhood of point features. So these, in our case, it's going to be these dots from ACLED data. And we can define our own neighborhood that's meaningful to us. And that can depend on your subject matter expertise. You can choose, for example, a distance band or a number of neighbors to create aggregation of those neighborhoods in order to summarize your data in a way that's meaningful to you. That's rather than aggregating by provinces or some other arbitrary boundary that might not mean a whole lot to you. You can say, okay, hey, within the next 3 miles or within the closest 20 dots, I want to aggregate those. And what we can do here is also choose the different summary statistics we want to print out. In this case, I'll just take all of them. And if you're not really sure about what kind of neighborhood type, you can also use this default Delaunay triangulation. You might have heard these called Voronoi polygons or Thiessen polygons. So right now what we're going to do is run it so that we can see where in the country has had the most fatalities per conflict event. And as you can see, it runs pretty quickly for us. And I'll turn off the ACLED data so that you can see this aggregation. And we even have a clipped version of it so that we can see it based on the boundaries of South Sudan. But we can see those darker blue neighborhoods, it automatically visualizes them by the mean for fatalities per conflict event. And those darker neighborhoods seem to be clustered around the north central area of South Sudan, as well as the southeast, or the rural southeast portion of the country. So here we're getting sort of this top level view of, hey, where are the areas that tend to have conflict events that result in more fatalities? And we've got that mean measure to help us figure that out, though the attribute table also includes the rest of those summary statistics that we indicated as well. And from here, you might say, well, Hannah, you're kind of painting with a broad brush because we're looking from 2011 to late 2020, early 2021 with this information. So let's bring in that third dimension, which is time in this case. And so we know we have that date information for all of this ACLED data. And what we can do is use some of our space-time pattern mining tools. And the first one that we want to use is create space-time cube by aggregating points. And what this basically does, is I'll change the name of it here, is it summarizes all of our points over these almost 10 years and aggregates them into bins within their particular location, bounded by a time span. So in this case, we can call our time interval, as we have down here, 1 month. But if you have a data set that spans 50 years, you might say, okay, a year is more helpful for my time stepped interval. And then we can also even choose summary fields, our aggregation type, etc. And when we run it, all it's telling us with the warning is that it's used the default distance interval, but now we have a space-time cube that we can use and visualize in either 2D or in 3D, like I have here. And so this is that very same data about conflict events in South Sudan broken into 3D space-time cubes. And it's that same interval of 1 month. And so you can see closer to the bottom is 2011 and closer to the top is current, or end of 2020. And as we're sort of exploring where the hotspots for more conflict events might be in both space and time, we can even click on a particular slice of the space-time cube to see, hey, well, in this area near Juba in August of 2018, there were 11 conflict events. So we can start to get a better sense of those spatiotemporal patterns as we explore a really rich visualization like this. But if we want to do more than just explore the visualizations in past patterns, we can also do that. We can take a look with another one of our space-time pattern mining tools, and this time we're going to use forest-based forecast. And what that does is it allows us to use our past trends. So we know we have all of this data about what's happened over the past 10 years for all of these different places. And we can use what we know about those past trends to predict what will happen in the future. So we can forecast for the next, say, 3 time steps, so that'd be, in this case, the next 3 months, how many conflict events we expect to see in each of those areas that were summarized by space-time cubes. And the interesting thing also with this forest-based forecast tool, a kind of new feature, even if you've maybe used this before, is that now we can identify outliers within the space-time model. So we're doing that in this case at a 95% level of confidence, so you can choose what level of confidence is appropriate for you or your problem. And what we're doing when we run it is essentially using a random forest regression model to predict what will happen next. And so we can run it. And I love to watch this run in real time because it is so fast. And we're doing some pretty complex modeling, but it really happens quickly. And I'll turn off the ArcGIS data so that we can see it a little better. And you'll see that in our forecast, the darker colors, again, are more forecasted conflicts in the next 3 months. So we can zoom in, say, to, we'll go back to this space-time cube near Juba, where we can see that the orange line on our pop-up is that forecast. That's what we just created with the space-time pattern mining tools, and the blue is what actually happened. The blue is our ground truth. So we'll see that we're forecasted, it looks like somewhere between 2 and 3 conflict events per month in this area for the next 3 months based on past trends. But we can also see where in the model there were these outliers. So for example, these purple dots are outliers that were above the fitted value. So there were some places where the forecast, the modeling couldn't quite reach, especially these high peaks, but overall it looks like it followed the rest of the trend pretty well. So this might be a place to watch as we go into the next 3 months. And I do want to note here that once you have a pretty compelling output like this one that's forecasting into the future, you can always share that as a web map, as a web layer, or even export it into a PDF or whatever report you're creating. So even a really complex output like this is totally workable in that sense. And so now that we've kind of gotten into this forecasting mode, the next thing that we might be interested in doing is figuring out how we can best prepare to respond to particular conflict events. So we know that there have been countless violence against civilian attacks in South Sudan over the years, and there's likely to be more coming up. So what sort of tools can we use to make sure that the places that are hurt by these events get the help that they need? So what we might want to do is look at an instructive past event to see what's going to happen or what could happen if we do our analysis well. So in this case, this is the town of Kajokaji in South Sudan. It's actually, if we go back to the map, it's in southern South Sudan. And a couple of years ago, there was a wholesale burning event in the village. So we have an image, you're looking at the pre-burning image here, and there's also a post-burning image showing all of the extensive damage in the city. And so what we might traditionally do is, as analysts, we go in, say, okay, which ones of these buildings were damaged? Where needs the most help? In the future, which places do we need to send census enumerators to, and which places are no longer habitable? All of those sorts of questions. But what we can do to kind of reduce the burden on analysts who would normally have to do that is implement deep learning for both extracting these building footprints that you see sort of outlined in red already, and classifying buildings as damaged or undamaged. And we're hoping that by implementing deep learning, it'll save a ton of time. And so just to be clear, with our deep learning, what we're talking about is a specific type of machine learning that applies a technique called deep neural networks to mimic the way that the human brain learns. And deep learning is becoming really good at processing and understanding high dimensional data like images. And generally speaking, ArcGIS supports 4 different types of deep learning models for imagery. And those are listed here. They're pixel classification, object detection, instance segmentation, and image classification. And image classification is the technique we'll be using for our damage assessment today. But ArcGIS actually goes beyond those explicit deep learning tasks to do image management. You can do that really robust analysis, and you can send out your data in a dashboard or a field app to use as well. So if we're going to do this deep learning, how do we get started? Well, the first thing we're going to want to do with some of these building footprints here is collect training data. And there are several actually different ways that you can collect training data depending on the deep learning that you're doing in ArcGIS. But in this case, what we're going to do, or what we likely did do already, not going to do it in real time, is we created a class value field and labeled several, and by several I mean 400, of the buildings as either damaged or undamaged. A building of 0 is undamaged and 1 is damaged. And so what we're doing here by labeling these is creating some examples for the deep learning model so that it can begin to understand what does a damaged building look like and what does an undamaged building look like. And as many examples as we can give the deep learning model, the better it'll be at figuring out for our entire data set which buildings are damaged and undamaged. And I'll move over to our workflow here just to give you a little bit of a sense of how this whole end-to-end deep learning works. And I wouldn't necessarily run it all from this model, but I think it helps you kind of conceptualize how we can do all of this in ArcGIS Pro. So the first thing we do once we have our labeled building footprints that I was just talking about, we can then use the Pro export training data for deep learning tool that exports images or image chips along with labels and associated metadata that can then be fed into our model training workflow. And we now have the ability to fully train our deep learning model right here inside ArcGIS Pro. And you can also do it with Python code using our Python API. And if folks want to discuss that more, we absolutely can. And I'm happy to field questions with that toward the end. But we're going to stick with the Pro-based tools for now because I think it's so powerful that we can leverage these algorithms with really no coding experience required. And once we're training this model, you'll see that we have a couple of outputs here. One is the actual model file, and the other is some information that comes along with the model. So you can begin to check, hey, how's my model doing? Does it seem like I had enough training data? And if you're happy with it, then you can feed your model right into the classify objects using deep learning model. And what that does is it checks to see whether each of the buildings in our entire building footprints feature class was damaged or undamaged by the wholesale burning event. And the output is a damage assessment. And I have an example of what that looks like. So turn it on. In this case, the undamaged structures are a yellow hue and the damaged structures are a red hue. And we can immediately share this feature class out for others to use, or we can turn it into an ArcGIS dashboard like this one, where you can explore those damage assessments, estimate the population affected, look at the status of buildings assessed if you have people on the ground, and even use a swipe app to look at the before and after images of the village. So you can see that there's really an end-to-end cycle of deep learning within ArcGIS. And you define your problem, we've collected training data, trained the deep learning model, run inference, and then we're able to build a great dashboard like this to supply information to people on the ground to use in decision making. And using ArcGIS really reduces the barrier of entry for AI through software that supports the entire deep learning workflow. And hopefully the goal is to really save image analysts time. That's why we do this. So with that, now that we've kind of seen all these different things that you can do in ArcGIS Pro and even brought up a lot of our data into this web-based application, I want to switch gears just a little bit and show you ArcGIS Insights, which is a tool that makes it easier to apply some powerful spatial and statistical analysis to existing workflows in a quick way. You drag and drop interface for location-based data analysis. And so ArcGIS Insights, I think, is especially interesting if you have some people in your organization who aren't necessarily GIS experts, or but they still want to do some location-based data analysis. And it's also really cool, even if you are a GIS analyst, to work with this and quickly make interactive reports that you can share with your colleagues, that you can share with your leadership. I think it's good for all of those things. So it's sort of an accessible interface that can be used by a wide variety of folks. So we're going to use the drag and drop interface and Insights right now to explore a Persons of Concern data set that we got from the United Nations High Commissioner on Refugees, or UNHCR. And why we're interested in this right now, sort of in the context of the South Sudan work that we've been doing, is that we want to know, hey, well, we've seen that there have been some pretty catastrophic events that have happened in South Sudan, and many people have had to flee their homes. So we might be interested in saying, well, where did they go from there? Did people stay in South Sudan? Did they move to other countries? If so, which other countries? And luckily, this data, these Persons of Concern data, has a lot of information about that. And you'll notice that this was actually, it started out before we brought it into Insights as just a CSV. So this was a comma separated values file. We had an Excel, and it doesn't even have latitude and longitude points. But we were able to location enable it because it had a country field. We brought in our world countries data set from the Living Atlas. And so from here, we can start to make some really compelling visualizations right away. For example, we can create a link map. It renders super quickly, showing both the country of origin and the country of residence as those light orange nodes, and then the link between them is obviously the line. And if we size our nodes using in degree, that'll create larger circles for those countries who have migrants from more countries seeking asylum there. And we can even style how our nodes and links look. There's a lot of different options available here. And now that we kind of have an overview map, and I just want to know this is over 60 years of data, so there's a ton of links going on here. It's 1951 to 2017. We might want to also break this down into a couple of extra charts. So the first thing I wanted to is bring in our country of origin data and create a bar chart with it, or a column chart, I think, actually. And what we can do also in the newest version of ArcGIS Insights, that's 2020.3, is we can now filter for an N number of records with the highest or lowest value. So if we want to know, hey, what were the top 10 countries that were origin countries for refugees, places that refugees fled in the past 60 years, we can do that. And we can even sort it by descending so we can see the top to bottom. And you'll note that this little chart statistics field allows us to print, we have the mean showing right now. We can also print the median right on our chart statistics. There are some really quick and easy statistics that you can calculate in your visualization. And as we move forward, we can do this with country of residence as well, and try a different type of chart, maybe a bubble chart, and bring that into just the top values as well. And we're starting to really create a compelling visualization here. And you might notice that now we're not even really looking at South Sudan at the moment. But if we filter with a predefined filter, which will filter all of the cards at the same time, we can just look at particular years. And especially since we know that the conflict in South Sudan started in 2011, we can begin in 2011 to see if that really illuminates more of the data that we're interested in from South Sudan. I'm just checking all of these years here. And it turns out that, yes, now we can see South Sudan. It turns out that, wow, 14 million people had fled South Sudan over those years. And we can see then that all of the places where South Sudanese refugees have gone, and some of the places, some of the higher amounts of places where they've gone as well. So now that we were able to just quickly find find some pretty interesting things about South Sudanese refugees in just a few seconds of exploring with ArcGIS Insights, we can also share out our entire sort of workflow with the view here that we can go to our analysis view and share out so that other people can do a similar thing for other countries that they're interested in, or other data sets that are similar. They can follow our entire workflow as well. And we can, when we're ready, we can share this page out as an interactive report too. So, and that interactive report will allow people to go into the analysis view, see what you did, come back out, and also interact with all of the cards on your page. So with that, that's kind of a quick introduction to Insights and some of the really fun things that you can do in there. And I think I'll pass things over to Kelly next, because I think we have a poll question coming, and then Parker will jump in.
Yes, thank you so much, Hannah. That was an amazing presentation. So we have a quick question for our audience today, and you should see that on your screen right now. What area would you be most interested in learning more about in data science? And you can pick multiple options there. We have data engineering, visualization and exploration, spatial analysis, machine learning and artificial intelligence, modeling and scripting, and sharing and collaboration. All right, thank you so much. I'm going to go ahead and close this out and share the results here on the screen. So it looks like it's pretty even, but most of you are interested in visualization and exploration and spatial analysis, machine learning and artificial intelligence, and modeling and scripting there is close behind. So again, we thank you for that participation. We appreciate it. It helps us gauge, interest in our audience and bring relevant content back to you. So again, I will throw this over to Parker to show us our next demo.
Great, thanks, Kelly. So hopefully you can see my screen and you can hear me all right. See the GDL project, hopefully.
Yes, we can.
Yep,
Thank you, Parker. We got you, Parker.
Perfect. So thanks Kelly for queuing that up, and Hannah for the great presentation. So in this section, we're gonna kind of continue on that theme of looking at the South Sudanese crisis. Specifically, we're going to use this data set. It's called the GDL project. It's an open source project. It stands for the Global Database of Events, Language, and Terror. And what they do is they run web scraping against tons of news sources, run it through some proprietary natural language processing algorithms to identify key entities within the data sets, and then also identify the tonal response of an article. So they'll look at a news report and say, is this a positive or negative article? And then they expose it through their open API. So using their API, we can actually go ahead and query out to find data by locations or by keywords. What we'll see is actually they do produce things in a GeoJSON format. So we'll have a point location that represents an article at a varying resolution. And within the properties, we can see things like the publication date and time, the name of the article, the tone of the article, was it a generally positive or negative sentiment, and then the URL itself to the article. And ultimately, what we want to do is find ways to access this external data source, normalize it, provide some analytics, and then integrate it into a decision-making product. So our end state here is going to be this dashboard, just something very simple that's showcasing trends of tones towards refugees per country, and then maybe overlaid with things like incident counts. So to do that, we're actually going to utilize the ArcGIS Notebooks server. This is kind of where we want to start. So over the last couple of years, we've been doing a lot of work to integrate Jupyter Notebooks and interactive Python notebooks directly into the Esri ecosystem. This starts with the notebook server available in both your enterprise environment and ArcGIS Online. And what this does is takes the Jupyter Notebook and applies it to, or makes it accessible from within your organization. Jupyter Notebooks are the data science tool is fairly widely proliferated and different from your normal Python IDE. It utilizes cell-based functionality. So you'll see each one of these little cells has a number next to it, and it allows me to step through processes, and I can rerun cells without having to rerun or recompile an entire script. So I've already imported a couple libraries, and utilizing the ArcGIS GIS component of the ArcGIS Python API, I connected to my organization here, and I just confirmed that I'm still connected. I pulled up my bio, so I have a little bio, my name, my picture. The first thing we want to actually do is go ahead and start pulling the data from the GDL. What we're going to really focus on here is how we can utilize things like notebook servers and these Python notebooks to normalize these different data sources, kind of clean it up and make it ready for analytics. So what I've done here is I've actually constructed a URL query. Using that, the GDL API project, they have the ability to make several different queries. Within there, I can see that I can query in the format. In this case, we're doing GeoJSON. And the query itself, you can query by language, a text, and a timestamp. I've created a variable here just for my text, so I'm querying for refugees specifically. I want to see articles about refugees or that are tagged relating to refugees. I can comment eliminate this and add multiple tags if I want. And then I have a time span variable as well. I've set this to 1440. The time span variable goes in minutes, so that counts to 24 hours. And what I've done is I've loaded up the JSON response, and I can visualize it right here in the web, confirm that I'm getting the same thing that we just looked at. So I can see I'm pulling in a GeoJSON. There's some coordinates and the same variables we saw before. Now, one of the really common ways to explore your data, especially a good tabular data, something like a CSV or pulling from another database, is using the Pandas data frame. It's a great data science tool. It has a lot of built-in functionalities to get things like averages, means, and standard deviations of your data. But what we do have to do is we have to morph this data a little bit to get it in there. So what we've done is we've written a GDELT dictionary handler. And what this is essentially doing is using that JSON that I've returned from their URL and creating a data frame with columns for the latitude, longitude, URL to the article, the URL tone, and the publication date, which is what I think I need for my analysis. So I've gone ahead and run that, created that function, and now I can apply that directly to my dictionary. And it should run pretty quick. It's just generated a full data frame. I can see that there's, using the shape function, 573 entries in this data frame from the last 24 hours. And I can see the top five, I've displayed the top 5 rows. So I have the latitude, the longitude, the URL to an article, and then the tone and the publication date. So now I have something that I can actually start to do some analytics against. And what we're going to utilize specifically is the spatially enabled data frame. This is a really fun part of the ArcGIS Python API. It's one of my favorite tools to use. I use it every day with my job. Within there, there's 2 specific things we're going to utilize: the GeoAccessor and the GeoSeries Accessor. And what these are extensions to the Pandas data frame that allow us to utilize spatial data and do spatial analytics. So I have functionalities to get the centroid of a geometry, or I can do other types of comparisons. I have the ability to create these spatially enabled data frames from a regular Pandas data frame just by providing a geometry column or an XY column. I can load these up from feature classes. I can load it from feature layers. And then once I've loaded, I can use the GeoSeries Accessor, which is what allows me to do analytics against specific columns in my data. And this exposes a lot of that native ArcPy functionality we tend to use in Python scripts. Things like an angle and distance to, getting point geometries, calculating out boundaries of our data. There's a lot of great things to play with, and the developers at ArcGIS.com Python API reference is a great place to explore that. So what I'm going to do here, and just in this cell, is, and you saw how quick that ran, I'm taking that data frame we just created with our data frame handler, and I'm going to turn it into a spatial one by applying the latitude and longitude field columns. And what I see in my new output here is there's now a shape column, and that shape column is using a JSON structured shape. So now I have something I can actually display and play with. So using the native functionality, I can actually just go ahead and publish that directly to my ArcGIS Online organization, my portal environment where I'm operating. I can save this locally as well. So what it's doing right now is it's reaching out, it's creating a layer called GDEL query January 14th. It's putting it in a folder, and then it's going to display the result here. So just like that, it's published up. And now I can actually go over to my map in my browser here, and I can see that same layer we just published. Once I put it on the map, I can go down perhaps to Sudan, click, and I can see there's 17 articles that have just been added in as points. I can click through those. I can get to their URL, and I can see their tone. So now I have something I can do an analytic against. Perhaps I want to go ahead and pull in a world countries layer. I can do an analysis using some of the built-in functionality of our enterprise environment here. So I can do a summarize of the data, perhaps summarize within. This tool runs pretty quickly, but I've already run the output. And I just kind of want to visualize what that looks like. We're going to go back into the notebook, and we're going to see how we can script this out completely in the notebook. So right here, I've created that output layer. And I can see that the darker the color is, the more positive the tone is. As it turns out, at least in the last 24 hours, we don't have any articles that have a positive tone. Everything is negative towards any type of refugee news. But the darker is a bit more positive, and the lighter is a bit more negative. So we'll go back into the same notebook, and we'll head down here to my last section, the run analysis. So the first thing we need to do is we do need to get that world countries layer so we can aggregate. There's a couple ways to go about doing that. So I could use the native GIS content search. I can search for world countries. It'll look outside of my organization and show me a few, and then I can pick one and declare it as a variable. Alternatively, one of the really cool parts of using this notebook server is the integration to the Living Atlas and to ArcGIS Online. So I can just search for world countries here and actually just add it. It'll go ahead and create a reference to that for me. It'll give me the item URL. It'll use that GIS content yet, and then it creates a variable for it. I have a variable here I've already renamed, so we'll just use that one. I can go ahead and add that and my GDEL query layer directly to my map, or to a map here in the notebook, so I can kind of visualize what my data looks like before I start doing any heavy analytics and start putting it into or publishing content out. I can see the exact same data. I can see all of the same features. And so now I can actually just run the analysis here. Now this is a place where we can use all the types of analyses that come in that ArcGIS Python API, which is it's in depth. Everything from point aggregation to extending what Hannah showed earlier. She showed components of the ArcGIS.learn module. That's another capability here within this within the Python API. I can actually go visit the documentation for it here. All the same functionality she showed in the web using that GUI. Should I want to script that out or run that at a larger scale, I can access that here in my notebooks. And I can see that it's already gone ahead and published that tone. Now, one of the really cool things here is I can share this. I can share this out with my organization to specific groups or publicly to anybody who can access my system. So now somebody else can go download this notebook and run that same analytic, perhaps with a different tag. Maybe instead of refugees, they just want to change it to some other type of conflict tag. They'll have the ability to do the same type of analysis. And to take it even a step further, we have a capability in our notebook server called tasks. What I can do is create this task. So I'll give it a title. I can give it any parameters it needs, and then I can set a schedule. And basically what this will allow me to do is I could schedule this to run every 30 minutes, every hour, once a day, and I can give it a time to stop. Perhaps I only care about events for the next 2 weeks. This will allow it to constantly update and keep running that notebook in the background. And again, we can apply that to some of the great concepts Hannah showed. If we have daily imagery collections, we can use AI, we can use our AI models we've trained with ArcGIS.learn and a notebook to run that every day against our new imagery collection. And we can use that to connect to proprietary data sources. And ultimately, what I'm hoping to do here is update this dashboard. So every day I want a new count of what's happened in the last 24 hours. So I can see if there's sentiment changing. And I can compare it with things like incident counts and timeline to kind of see, is there more incidents? Is there more disdain, more frustration towards the events going on? So that's just a quick overview of really how we can use ArcGIS Notebook Server to integrate these different data sources, bring them together, run some analytics, and script them to make them repeatable results. So with that, I'm going to go ahead and actually pass this back over to Kelly for another poll question, and then to Linda to open up our question and answer section.
All right, thank you, Parker. So again, we have our last poll question for you today, and what we want to find out is, are you using data science method or spatial analysis in your organization today? All right, and thank you. I'm going to go ahead and close this poll out, and I'll share the results here. So it looks like 47% of you have been using data science methods or spatial analysis in your organization with, yeah, good majority. The rest of those answers there are pretty even. 17% you're brand new to GIS and data science, so we hope this presentation is helpful for you, and we'll be providing some resources for you at the end. So again, thank you for your participation. We appreciate that. And with that, I will go ahead and hand it back over to Linda to close us out and to run some question and answers for you.
Great, thanks, Kelly. And I do want to make sure you can see my screen and the slide that's up there.
Yes, we can.
Perfect. So I just wanted to wrap us up. We saw a lot of different things from both Hannah and Parker. And, you know, of course, the challenges we all face across national government today are many, and they range from, you know, expanding expectations, you know, the demand for a broader range of information products, and of course, more and more information being needed in real time. And of course, budgets are shrinking. We have fewer staff, fewer resources. So we look at data science and think about how it can help us address some of these issues. And hopefully you saw today that it can help us in becoming more responsive, speeding the time of information delivery to decision makers. Expanding the use of technology and data analysis helps us with that information delivery. And of course, overall helping us increase our efficiency and expanding our capacity. And last but not least, improving our accuracy, right? We want to get data out there that's accurate and authoritative and as quickly as possible. There's a lot of resources we've got available for you. Again, as Kelly mentioned, we'll share the video, we'll share a PDF of these slides as well, excuse me, with all the appropriate links that you see here. But now with that, I want to thank you for your time, and we want to throw it open for your questions, and we've got quite a few of those. So perhaps at this point, I'm going to open up the questions window and get us started there and go through some of the various questions that we've been asked, because there were a lot of really good ones along the way. And excuse me, Hannah, I think the first question that we had was for you. The question came to us from Michael. With forest-based forecasting, do you get prediction errors around the predictions?
Yes, you do. You do. You actually get a confidence interval around all of your predictions. So, yes. Short answer in this case.
Yeah, short answer. That's good. Second question was, are there training courses or learn lessons in the various use cases? And if so, can you share the links? And as you saw on the slide I just shared, there are many links, including one to the Spatial Analysis MOOC. And from that page, links to many of the different learn lessons that are available. So again, if you can take a look at that when it comes out, you'll see there's a lot of things out there for you.
Especially if you're a Python developer, there are a ton of sample notebooks on the Python API website that I would really recommend doing. You can do stuff like Parker just did, or deep learning with the Python API. So there's a ton of resources for that.
Yeah, great point.
One more thing with that too, Linda, come on. We recently have started open sourcing some pre-trained models on ArcGIS Online, so you can go search for the deep learning package, the DLPK. And if you search there, you'll find some models for basic LiDAR classification, but also building footprint detection from overhead imagery. So that's something great to start playing around with to get your hands on the tools that you don't necessarily have all the training data.
Great, thanks, Parker. Let me see, next question. I think this is also for you, Hannah, on the damage assessments, thinking post-disaster environment. This is coming from Quentin. Can we estimate the percentage damage on a structure, for example, 25% or 50% versus 100% damage, and train the model to do the same?
Sure. I mean, I I think the way I would approach that would be to create classes for each of those. So if we're like, we did damaged versus undamaged, but if we did damaged, like fully damaged 100%, partially damaged 75%, kind of damaged 50%, and made those into all of our classes, you can absolutely do that in basically the exact same workflow that I showed, just making sure that you make those distinctions in your training data.
Great, great. Thanks for that. Let me see another question. I don't know who can answer this, either Hannah or Parker. Can we use deep learning to classify agricultural crops using imagery from satellite and drones? Who wants to take that one?
I can go ahead and take it. Absolutely. So the kind of rule of thumb when it comes to computer vision, which is the specific subset of machine learning where we're recognizing objects and images, is it can't really replace anything a human can't do. But if a human can go in there and look at a piece of imagery and classify different types of crops, you can absolutely train the model to do so. I know I have seen some successful results there out of actually some UN groups who use the ArcGIS field apps, another great webinar to attend, to go out and actually ground truth, collect different crop types, and then using those features they've collected, you can go back and train your models against satellite imagery to do that.
Yeah, great. Thanks for that, Parker. Hannah, I've got another one for you. How well did the deep learning analysis work? What percentage of the data was needed for the training data set, and how many false positives or negatives did it produce? And is there a way for the user to explore and understand that?
So yes, yeah. And so when you are using the inference tool, so that classify objects using deep learning tool that I used, it gives you also a confidence sort of indicator on there. So it'll be like it's 0.92. It would be a high level of confidence that it believes that it is correct in saying that particular footprint in this case is damaged or undamaged. So that's one way that you can start to get a sense of how accurate your model is, or how accurate your model thinks it is in that case. But I mean, there are a whole bunch of ways you could approach it. I mean, when you're training the model, it does give you kind of an interactive, it actually prints out a whole little report where you can ground truth versus predictions that you can look at and say, okay, like how is my model actually doing side by side with what you think and what the model thinks. So I think those would be the kind of first ways that I would go about tracking that. I mean, when you get into using the Python API, there are a few different methods that you can run to get some accuracy metrics on your data. So that's a possibility as well.
Great, thanks. We're going to move on to a couple of questions around insights. First question from Elliot: is it possible to connect locally stored data to either the online or desktop version? And
Yep.
If so, is Insights equipped to work with big data?
So yes, you can put in any local data. I mean, you can upload any data to the online version, and you can connect local databases. You can do that on either desktop or on the web version. So yes, I mean, I would. The idea with Insights is that it will take in as many layers as you can fit. It can take in unlimited numbers of layers, so big data isn't really a problem for it. So yeah, you should be able to use your big data in there.
Okay. Moving on to a question for Pro. And I don't know, either one of you could probably answer this one. Does ArcGIS Pro have more powerful analytical tools than ArcGIS Desktop? Who wants to take that one?
I can dig into that. So the answer is really it has all the same functionality as ArcMap plus the newer functionalities. So the tools that Hannah showed, those new tools that are coming in ArcGIS Pro 2.7 or the recent release 2.7, are tools that will not be made available in ArcGIS Desktop. All new development and functionality is now being pushed to ArcGIS Pro. And then, of course, there are tons of great ways there are tons of great ArcGIS learning lessons on migrating to ArcMap, from ArcMap to ArcGIS Pro. So those will also be available from the training links that are being sent out. So if you have questions about that, those can kind of help you start moving your organization.
Great. I know we're ticking down on time. Let's see if we can knock off a couple more questions. There was a question on forecast models. How many forecast models are available in Pro, especially those that can be used in land cover change forecasting?
Sure. Well, we have a few different forecasting models. I mean, if the question is referring to like the forest-based forecasts that I use, that's more for something that has a space-time component rather than a particular like land cover change. But there are certainly different ways that, whether it's per se a forecasting model, there's if you have a multi-dimensional raster, for example, that you want to use to per se do your image analysts over time to try to see what crop indicators might be like for the future, that, I mean, is definitely a possibility. I'd have to do either of you know the particular number off the top of your head of how many tools? We certainly have a number of tools that will do that. I don't know if I have. Yeah, I would say like 7.
And then when it comes to deep learning models as well, I think we're piggybacking off at least 8 or 9 different models that are available with ArcGIS Learn now too. Everything from like a ResNet to a single shot detector.
Right, and a lot of those are even customizable so that you can use a different backbone to your model if you don't like the way that a certain model trains. So a lot of customization available in terms of different models for forecasting.
So I'm going to wrap us up with one last statement here. There are a couple of other questions that we didn't get to in the chat. We'll try and answer those if we can directly. There was one about using the trainings and webinars within your own organization, and certainly all of this content is available post-webinar. We keep that up and make it available, including the presentations, and as well as access to some of the Jupyter notebooks and samples and training. So we'll make sure to get as much of that information shared out post session as well. With that, I want to throw it back to Kelly to wrap us up and bring us to close. And again, thank you all. Appreciate all the great questions and your attentiveness. Kelly?
Great, thank you so much. And Linda, Hannah, Parker, thank you for those amazing presentations and demos. This was a great webinar, and I want to thank our audience for joining us today. We appreciate your time and your participation. There is a survey that will launch at the close of this webinar. It'll also be linked in the follow-up email, so if you can take a few moments and fill that out, it would be greatly appreciated. And again, as Linda mentioned, the recording of this webinar along with the PDF of the slide deck and some additional resources will be available to you, and that should be going out in an email within the next couple days. So again, thank you so much. We appreciate all of your time, and we look forward to seeing you on the next webinar. Thank you.